Okay, one slight topic that I forgot to cover in the last video is the concept of shaft design. So as we look at it, we know that the maximum shear stress in a shaft is going to be the torque times the outside radius divided by J. So what we're looking at here is all about the shear stress, because maximum shear stress, that's when things are going to break. The interesting thing to note, though, is C and J are a geometric property that never changes. Because once you have your cross-section there, it's not going to change. So what happens is your torque and your shear stress are the only two things that really come into play. So what you can see sometimes is this equation will get rewritten as J over C is equal to torque over the maximum shear stress. And so this allows you to have a design ratio, and you can design the shaft based on what your maximum torque is going to be, which you can find in the using the power equation, over what the shear stress is. So you can go and figure out how much torque there's going to be in a spinning transmission shaft. Come back here, your maximum shear stress will be dictated by your material, and then you can use that to solve for J over C. And so this helps you figure out what your design of your shaft should be. And it can get a little bit simpler because in the, say you have a completely circular shaft, well, what is J? Well, J is going to be pi over 4 times the outside radius to the 4th over C. Now, the outside radius is the same thing as C in this case, so what ends up happening is your J over C is just going to be, okay, well, that's pi over 4, almost right, pi over pi over 4 C cubed. So, if I know that, okay, my shaft is putting out, say, 1,000,000 watts of torque, and my maximum shear stress is 100,000 megapascals or whatever, you can easily back work out what the diameter of that shaft should be to allow it not to break. And so once again, all we've done is we've collected the geometric terms to one side, and then we have the torque and the shear stress term on the other side, and we can use that to calculate out the design ratio and calculate out how we're going to do our shaft.